Trisha Gray, and I work on the RealityKit tools team. Welcome to Build Great Games for Spatial Computing. I am really excited to talk to you today about making games for this new device. Spatial computing makes all sorts of new game types possible. It has unique rendering, audio, and input characteristics. You have several choices when it comes to which frameworks and tools you can use to build games on it. And that includes RealityKit. But first, I'll give you an idea of what types of games are possible on this new platform. This is a standalone spatial computing device. It has high-resolution screens, a wide field of view, and a great refresh rate. The spatial audio is amazing. And there's LiDAR that tracks both hand movements and the shape of the room around the player. And players can stay connected to their surroundings using the device's high-quality pass-through. This has exciting possibilities and lets you create a wide variety of different game types. You can build games that span a spectrum of immersion, all depending on how much of the player's attention you want to capture. All apps and games start in the shared space. This means that your game can live in space together with other games and apps and the player's surroundings. There might be a virtual chessboard on the player's actual desktop representing an active game of chess, or a virtual pet sitting on the floor. All of these apps live together and the player can interact with whichever one they want. You can put all attention on your game when you move into full space. This closes all other windows and volumes, focusing the experience on your content while still keeping the player connected to their surroundings through pass-through. This might be suitable for an action game, something you're actively playing, but that still interacts with the real world. You can have spaceships coming through a hole in the wall, for example. A fully immersive experience is when the game takes over the whole view. Instead of your room, there's an environment, and you can no longer see the real world. Of course, you can also make traditional 2D games. They run in a virtual window, and the player can make that window as big or as small as they want. It doesn't even have to be a vertical window. It could be a flat surface lying on the ground. They could hang it on the wall, or put it on the desk, or have it as the largest screen they've ever had right in front of their face. Players can interact with your game just as they would on iOS, but instead of touching the screen, they'll look at an object and tap their fingers together to select it. You can also connect a Bluetooth controller or a keyboard just as you can on iOS. And the pass-through is helpful here because you can look down and see the controller you are using. You can also spice up a 2D game by adding some 3D elements to it. For example, your window has real depth, so you can render your objects in separate layers and get a real parallax effect. You can also have elements that come out of the plane, such as smoke or sparks, or you can add support for custom hand gestures. With all these options, you have a lot to think about. As you design your game, think about how you can take advantage of these new opportunities for gameplay experiences, from having a giant high-resolution screen to having something personal that you can play in your own room. Your game can appear on the player's desk, they can place it on the wall, something can fly out and land in the player's hands. You can make use of the real world around them or transport them into an entirely different place. Rendering, audio, and input work differently on this device than you might be used to on other platforms. When you're running in a shared space, the content from your game is drawn together with content from other apps, System UI, and pass-through. Since the rendering is shared, the frameworks ensure that all apps are good citizens, and their rendering doesn't interfere with other apps. In this mode, you can use surface shaders and geometry shaders through Material X. Rendering on xrOS works a little differently than you're used to. Instead of rendering every pixel, you describe what should be rendered, all the models, textures, and shaders, and then the device renders it automatically for each eye. Another benefit of the platform rendering for your game is that it can apply dynamic foveation to increase the resolution. Dynamic foveation is a technique where the renderer uses higher resolution at the part of the display where the player's eyes are looking. This means you get crisper resolution in those spots without paying the cost of rendering the whole scene, all without having to do any of the hard work. By default, RealityKit renders your objects in such a way that they blend in realistically with the real-world objects around them. RealityKit will sample the actual lighting in the player's room and apply that same lighting to the objects you render. For materials, RealityKit uses a physically based lighting model with typical parameters such as roughness, specular, and metallic. This together with the sampled lighting gives you a realistic look. But you can choose where you want to be on the scale from realistic to fantastical. Instead of using the built-in PBR shader, you can create customized shader content using Material X and edit the shader graph in Reality Composer Pro or other graphic packages. You can also assign custom IBLs to your object for custom lighting effects. Another consideration is that there are some system-wide effects that get applied to rendered content. The purpose of this is to make your game work better with other apps and protect the player. Depth mitigation makes your content slightly transparent when it's hidden behind objects in a player's surroundings. This gets rid of the feeling that objects are floating in the room. Near-field vignetting fades your content when the player gets too close to it. This prevents issues with your content clipping against the near plane. Breakthrough allows someone who is approaching you to break through the rendered view, so they don't run into you without you noticing. Finally, grounding shadows are added to rendered objects when they are placed near real-world objects to make them feel more integrated into the scene. Fully immersive rendering works similar to shared rendering, but in this case, instead of sharing the screen with Pass-Through and other apps, your app is the only thing visible. In this mode, you render an environment that replaces the real-world view around the player. Rendering in this mode works similar to rendering in the share mode. You still describe the scene, and the device renders it. But since you control everything the player sees, you have more freedom. For example, you don't have to use the same lighting environment as the room the player is in. You can make the world as bright or as dark as you want. The strength of the device lies in the shared mode, but fully immersive experience is there when you want to transport the player to a different place. If you'd like to write your own engine, the Compositor Services API gives you access to metal rendering on xrOS. You can combine it with ARKit, which adds world tracking and hand tracking to create a fully immersive experience. In this mode, you have full access to the screen and render the scene for each eye. You can use fully custom metal shaders and post-processors. This enables you to completely replace real-world content with your own virtual content. Pass-Through and other apps are hidden. For more information on this, check out Discover Metal for immersive apps. Audio can be immersive too. xrOS uses spatial audio to bring objects to life in the player's space, automatically matching the reverb in the real room acoustics. If you play audio using standard iOS audio APIs, such as AV Audio Engine, the audio will be positioned relative to the app window. If you want sound to come from different objects in the scene and the player's space, you should play the audio through RealityKit on specific entities in your scene. You also have the option of doing your own audio using any Apple or external API. If you want the audio to be head tracked, you need to use ARKit to get the player's head position. In addition to graphics and audio, interaction is another key part of an immersive experience. After all, every game needs input, and this platform offers multiple ways to interact with the device. You can get input events on the objects in your scene through SwiftUI, as well as other standard system gestures, such as dragging and magnifying. This is based on the physics collision. To make the gestures work on your objects, they need to have both a collision component, which provides the collision shape, as well as an input target component, which marks them as interactable. Spatial input can feel pretty magical for players, but you have other options for game input too, even game controllers. While system look and tap gestures feel natural, you only have one set of eyes to look with and only two hands that can tap, pinch, or grab. Some games need more points of input. One possibility is to use a standard Bluetooth controller. xrOS supports trackpads, mice, and keyboards, as well as Bluetooth-based game controllers. This can be a good option for traditional games. And xrOS also allows for more unconventional input, such as using your own body as a controller. You can use hand tracking to let the player grab virtual objects or implement custom gestures, such as pointing at an object or karate chopping them. You access hand tracking through ARKit, and the device will ask the player for permission. same as when an app wants to use your location or microphone. There are some things to consider when designing this input. Hands can only be tracked when they are visible to the camera. Really fast hand movements can be hard to track. Take that into account. When you are working in a full space, you can request scene understanding. Scene understanding provides a virtual mesh representing the room around the player. It can also do plane detection to find horizontal and vertical surfaces. You can also get the materials of those surfaces, whether it's carpet or wood. This lets you use the room itself as part of the input to your game. Just as with hand tracking, this requires permission from the player. With all the input options, you have to figure out what is right for your game. Using the player's body for direct input is a great way of engaging them. But holding your hands up and doing gestures is also something that can get tiring over time. If your game will be played for long stretches of time or require a lot of quick actions, think about how you can make use of indirect gestures and gaze. That way, players can rest their hands comfortably on their lap and look and tap instead of moving their hands. The device is meant to be something you use every day, so comfort is important. And if it makes sense, you can also go to a more traditional game controller. This platform supports all the multiplayer and networking capabilities you are familiar with from other platforms. Web-based networking, low-level socket-based networking, and multi-peer connectivity are all available to you. SharePlay also makes it easy for the player to socialize in a more intimate way. You can even build games using networking that allows some players to play on iPhones or iPads and still connect to this great device. Imagine a dominoes game with your friend that has an iPad, and they have a 2D experience, while you have a rich, immersive 3D experience. Now that you know a little bit more about this as a gaming device, here are the frameworks you can use to create games. Depending on whether you want to make a 2D game, a game that lives in volume, or a fully immersive game, there are different options available to you, such as using RealityKit, our immersive framework, or writing something directly on top of Metal, or even using Unity. If you have already made a game for iPhone or iPad, in most cases, your game will automatically run on the device in a virtual window, using look and tap to interact. Note that this applies to compatible 3D games too. They will run in a flat window on the device. If you want your game to be stereoscopic, you must use the spatial computing APIs. Being able to run compatible games is great, but if you want to take full advantage of the device, build your game to target it. That way you can use gestures for input or add 2.5D elements such as perspective or volumetric smoke. You can build 2D games for the device using a 2D framework such as SwiftUI or SpriteKit. You can use Unity to build games for xrOS. This is a great option if you already have a Unity game that you want to port, or if you are a Unity developer. If you want to learn more about using Unity, go to the sessions, bring your Unity VR app to a fully immersive space, or create immersive Unity apps. Finally, there is RealityKit, Apple's real-time rendering framework for building immersive spatial experiences. The API has a lot of new features to make it a great way of creating 3D games for xrOS. RealityKit supports all the features you need to make great games. There is an entity component system for custom behaviors, and an extensibility along with physics, animation, particles, and audio support. On the rendering side, RealityKit supports both USD models as well as custom meshes. For grounding your objects in the world, there are Material X and IBL lighting. Attachments, a new feature, which allows you to connect rich SwiftUI directly to your RealityKit objects. Using SwiftUI, you can mix pass-through and rendered content in various ways, using features such as windows, volumes, spaces, anchors, and portals. You can use system gestures for input, or you can use ARKit to access hand tracking and scene understanding. To start building your game for xrOS, you create a new Xcode project from the xrOS template. This gives you a SwiftUI window with the reality view inside of it. The reality view in the SwiftUI hierarchy holds the 3D rendering and simulation for your game. If you're not familiar with SwiftUI yet, it is worth it to learn a little bit about it. By default, your 3D content appears in a volumetric box formed by the window. Your content is confined to that window and will follow along as it moves. RealityKit is a Swift API. Swift can be a great language for building games, but if you want to use another language, you can. You just create a bridge between that language and the Swift API. Xcode comes with a simulator. You can start developing your games right away without having a device. Of course, testing it on a real device is always best. Your 3D content will, by default, be displayed in a Swift UI window. One of the first things you will want to do as a game developer is to break out of that window and draw content in the player's surroundings. You have some different options for doing that. You can use a volume. Volumes are similar to windows with one important difference. With windows, the player controls the size. They can drag the corner and make it as big or as small as they like, and your content has to adapt. If the window is too small for your content will be clipped. With volumes, it's the other way around. With volumes, you say, I want the box to be this big, this high, and this deep. The player can still put that box wherever they want in the world, but the box will always be the same size. So you can make sure that the box is big enough to fit your entire experience, and you can be sure that the content doesn't clip. If you don't want to use a box at all, you can use a space. This allows you to render content all around the player in the real world. For example, you can surround the player with buzzing bees. There are different kinds of spaces corresponding to the different game types. You can use a shared space to run together with other apps, or a full space if you want your game to be the only thing running. Anchors let you anchor your scene to an object in the real world and follow it around as it moves. You can use a horizontal or a vertical surface anchor to anchor the entity to a desk or a wall. There are also hand anchors that let you anchor content to the player's hands. Portals allow you to punch a hole in the player's reality to create your own fantastic reality. You can anchor a portal to a real wall and have that portal cut a hole in the wall that lets you peek into a rendered world inside the hole. You can render whatever you want inside that portal, and the objects inside the portal can emerge into the real world too. RealityKit can load and render USD files. One of the easiest ways to get started with volumetric content is to assemble scenes out of pre-made objects. But for that, you need some kind of visual tool. Reality Composer Pro is a tool that comes bundled with Xcode. It lets you load USD models and preview how they will look on the device. When you build your object with Reality Composer Pro, your assets are automatically optimized for use on the device. You can learn more about Reality Composer Pro in these sessions. I hope this session was a helpful game development roadmap for spatial computing. Be sure to take a deeper dive in the multiple framework sessions available. This is a great platform to socialize and play games with others. I can't wait to see what you develop for it.